Good morning, everybody. Happy Friday. This is it. This is our last day. Because next Monday, Tuesday, Wednesday is just get old stuff to me. If you want an A, you got to get everything in, okay? So if you get everything in, you got an A, okay? So you have all the way until Wednesday, probably, I don't know, sometime Wednesday, but, Wednesday noon. Okay, here we go. So answers from the review sheet. I have 8/10, 6/10, 8/6 for sine, cosine of A. But once you go to B, everything changes around. That's the opposite, and that's the adjacent. So then sine of B is 6/10, cosine 8/10, tangent 6/8. On this one, the first thing I did is found angle C, just subtract from 90, and then I set up probably opposite over hypotenuse. I probably set up sine, and then I probably used cosine to get this one, okay? I probably used sine inverse on my calculator of 5/13, and I ended up getting a 22.6 degrees, subtract from 90 and get a 67.4, and you can use Pythagorean's theorem to get that side, okay? On the back, these are 36 triangles, so 12 squares of 2. This is 20, so that's 10 squares of 3. This 12 is sitting right where the x squares of 3 happens to be, so divide by square root of 3 and you get 4 squares of 3, and then you double that because it's twice as big. You get 8 squares of 3, okay? You have to change the ramp to 4 feet as 48 inches. You have to do that. And then I'm going to do my sine inverse of 9/48. I get about 10.8. I went through this with you guys yesterday. You've got to make a triangle here, right? And you get 65 degrees. You get 12, and then you can find this side. By using cosine, you get the height by finding sine, and of course the triangle is 1/2 base times height, and I got a 55.15. Okay, so that's what I got. Today, the test. Here it is. So, if you want a copy of it, just ask, but I'm going to go through it with you. I'm going to set you up, okay? I'm not going to do all of it, but I'm going to do most of it, so you just have to follow along, okay? So first of all, here's the trick. If I want angle P, so you go to P. Here's P. Now think of it as a triangular lake. You throw the rock to the opposite side. So this would be my opposite side. I'll put that in pencil because I'm going to have to erase it, okay? Opposite side. Then this side's next to me. This is my buddy. He's adjacent to me. And the 25 is the hypotenuse, okay? So here's what we have. We know that sine of an angle is the opposite over the hypotenuse. We know that cosine of an angle is equal to the adjacent over the hypotenuse, and we also should know that tangent of an angle is equal to the opposite over the adjacent. So let's take a look at what we have, okay? So sine of P, sine, opposite over hypotenuse, 25/24, okay? Cosine of P is adjacent over hypotenuse, 7/25, okay? Tangent, opposite over adjacent, which is 24/7. Then we switch it around. We go to the other side of the lake, right? If we go to the other side of the lake, all of a sudden, then we have our angle right here, and we got angle G. So all of a sudden, now this becomes my opposite side. This becomes my adjacent side. So I want answers that are fractions. So from here, sine opposite over hypotenuse, like 7/25. Okay, so I want fraction answers for all these. Cosine adjacent over hypotenuse, 24/25. Tangent is going to be opposite over adjacent, 7/24. Okay, got it? So I want fractions because it says ratio. These should all be a fraction, just like this one. Okay. Now number 7, 8, 9. First of all, let's get angle A. Angle A is easy because you're just going to go for angle A. You're just going to go 90 degrees minus 64, and that will give you angle A. Okay. Now little a. Here's how it works. If this is angle A, this is little a, okay? Let's get little a. So, here's my angle, right? I know, what's that angle? I can do that real quickly. Hold on, I guess I could do that one. 90 minus 64 is 26 degrees, so it's 26, okay? So, opposite over hypotenuse, right? Opposite hypotenuse is sine, there it is. So we'll set up, and theta is 26. So I'll set up sine of 26 is equal to my opposite, which is little a, over my hypotenuse, which is 8. We'll multiply up the 8, and we'll use our calculator. 8 times the sine of 26, and use your calculator, okay, to get that answer, okay? Then if you want to find this side, little t, you could use cosine, because you'd have adjacent over hypotenuse. So same thing, just use cosine of 26 is equal to little t, because that's my adjacent, over 8. Multiply up the 8 and use your calculator, okay? Now, 10, 11, 12, let's find angle n first, okay? That is my opposite side, and that's my adjacent side, okay? So opposite adjacent is tangent. So I'm going to set up tangent of n, not theta, but tangent of n is equal to opposite over adjacent, 5 over 7. But if I want to find the angle, I've got to use the inverse button, tan inverse of 5 over 7. Remember? That's our button right there, tan inverse. So you're just going to type in, you're going to go second tan of 5 divided by 7. If you have to use your phone, it will work. Okay, so once you get this angle, I think it was a 35.5. Then you get this angle B from subtracting that from 90. And you can get this side, little e, by Pythagorean's theorem, right? You can go 7 squared plus 5 squared equals, this is little e squared, or a squared plus b squared equals c squared. You can do that, okay? 13, let's see my special right triangles. Let's draw it down here, right? X squared is 2. So 3, 3, and 3 squared is 2, right? Okay, there it is. 30, 60, 90 triangle. Let's take a look at that. So in a 30, 60, 90 triangle, x, this is twice as big, and this is whatever x squared to 3 happens to be. So if this is 18, that's got to be 9, and that'd be 9 squared of 3, okay? 18, half of that is 9, 9 squared to 3, okay? 15, the problem with 15 is this 24 is sitting right where this x squared to 3 is sitting, okay? So 24 is equal to x square roots of 3. So to find out what x is, I'm going to divide by the square root of 3. 24 divided by the square root of 3 is the square root of 8. Okay, so then that is going to be x, which is actually z in this case. So I'm going to have a square root of 8, right? And then I'm going to do then this side's twice that, or 2 square roots of 8. Okay, so moving on to the other side. Okay, this one's really easy. Seriously, I made it too easy, but that's okay. You guys don't mind if it's easy. 3, 3. R, you got to graph it. -2, 3. There is S, and -2, -2. There's T. Okay, here's my triangle, right? The reason this is easy, because 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It is basically 5, 5. It's one of our special right triangles. It really is. It's what we just did here. 5, 5. 5 squared is 2. Okay, so you know that length here has got to be 5 square roots of 2. Or you can use Pythagorean's theorem and get the decimals, okay? I also know this got to be 45 degrees, right? 45, 45, because it's half a square. So I'd go along with 45 degrees, okay? 17. Let's do it. 17, drop a 16-foot ladder, leans against a 10-foot wall. So here's my wall and a 16-foot ladder, right? So that's 16, 90 degrees, and a 10-foot wall, right? What is the angle formed by the ladder and the ground? That angle right there, call it theta. Well, check it out. That's my opposite side. That's my hypotenuse, okay? Opposite hypotenuse, opposite hypotenuse, opposite hypotenuse. Got to be sine, right? Opposite hypotenuse got to be sine. So we're going to set up sine of theta. That's there, equals my opposite, which is 10, over my hypotenuse, which is 16. Now, if I have to find the angle, you have to use your inverse button. So we're going to go sine inverse of 10 over 16 and use our calculator. Just type it in and see what you get. Okay, we're going to go sine inverse of 10 divided by 16. Hit the button and you'll get your answer, okay? 18. Okay, the shadow of a tree on the ground is 13 feet long. Now, shadows are on the ground, by the way, okay? So here's my tree. Here's my shadow. Shadow's 13 feet. So the angle of elevation to the top of the tree is 34 degrees. Right? What's the height of the tree? Just call it h. Okay, let's see what we got. We've got, from my angle, opposite and this is my adjacent, okay? Opposite, adjacent. So let's see, opposite, adjacent, opposite, adjacent, opposite, adjacent. There it is, tangent. Let's use tangent of theta, but theta is 34. So we're going to go tangent of 34 is equal to h over 13. There we go. Multiply 13 up and use your calculator. So 13 times the tangent of 34 is h. You just have to use your calculator. You have to get the answer, okay? 19. The big trick is here. Inches and feet. And I underline. So 3 feet is 36 inches, right? Okay, so we got a ramp. Wheelchair ramp, right? Here it is. This is the ramp. This is not the ramp. That's in the ground, okay? Or on the ground. But the ramp is 36 inches. And the height is 3 inches. What's the angle of elevation? So, here we go. Opposite, right? Opposite. And this is my hypotenuse. Opposite hypotenuse. Opposite hypotenuse got to be sine. So I'm going to use sine of theta is equal to opposite, which is 3 over 36. Again, if I'm looking for the angle, I got to use the inverse button on my calculator. Sine inverse of 3 over 36, right? Your inverse button is in blue, or if you use your calculator, it's the second button. Some people have a second button instead of an inverse button, but same thing, okay? Now, last page, okay? Let's get this done. An airplane flying at an elevation of 5,000 feet, okay? So let's draw that, okay? Here's my airplane. We've done this problem before. Okay, 5,000 feet. Okay, that means he's all the way up here. 5,000 feet. Starts to ascend towards the airport with an angle of depression. Now, the angle of depression is this angle. That's my angle of depression. And that's 5 degrees. Okay, so that also means that it's 5 degrees here. Alternate interior angles. Okay, so then we can use this triangle. How far is the plane from the airport? So let's call that just x. So if I use this angle, I've got my opposite and my hypotenuse. Okay, my opposite, okay, opposite side, and my hypotenuse. Okay, so opposite hypotenuse, it's sine, right? Right there, opposite hypotenuse, I'm going to use sine. So we're going to set sine of theta, but theta is 5. It's equal to the opposite, which is 5,000, divided by my hypotenuse is x. Now, if the x is on the bottom, we've learned you bring up the x. Okay, so the x comes up here. And you've got to divide by the sine of 5. So you get x is equal to 5,000 divided by sine of 5. Expect a big answer because you're a long ways from the airport, okay? Okay, expect a bit that you will get a big answer, okay? Okay, 21. Here we go. I need a right triangle. So the first thing I'm going to do is just make this into a right triangle, okay? And let's take a look at this half of it, okay? So if we need to find the base, BC, and the height, and then the area, okay? So let's first of all take a look at this triangle, okay? Superimpose the triangle over here. Just draw that right next to it, okay? There it is. There's my triangle. I know this is 9. This is 24 degrees because I bisected the angle. Let's call this x, okay? So to find BC, let's find x and double it. Opposite, right, from here, opposite over hypotenuse is sine again. So I'm going to go sine of theta, but theta is 24, right? Sine of theta, opposite of hypotenuse. So I'm going to go sine of 24 is equal to opposite. That's my opposite side, x over my hypotenuse, which is 9. I'm going to multiply up my 9 times the sine of 24. And I should get the answer, okay? So I use my calculator. 9 times sine of 24. Whatever I get, I'm going to double. So whatever that answer is, you're going to double, okay? Because you need both, okay? So take your answer here and take this answer and times it by 2, and that will give you the value of BC, okay? Now to get the height, let's go back to this triangle. Let's call this h. We can use cosine because this is my adjacent side and my hypotenuse, okay? So there it is. Adjacent hypotenuse is cosine. So we're going to set cosine of my angle, which is 24, is equal to my adjacent, which is h over 9. Multiply up the 9. I go 9 times the cosine of 24, right? Because you got to multiply up the 9. Put right there, and then use your calculator. That'll give you the value of h. Okay, so once you get these two, right, how do you find area? Area is 1/2 the base, which is the answer for BC, times the height, which you just found here, and you get the answer there. Okay, now, extra credit, I will set you up a little bit. Of course, obviously there are 6 equilateral triangles. We know out of 360 degrees, divide by 6, each of these are 60 degrees. So, if I take and look at one of these triangles and superimpose one of these triangles, right, then what I have is this triangle, which is a 60, 60, 60, because it's regular, so I know it's 60 degrees, 60, 60, okay? But I'm going to make it into a right triangle, right? And that makes it a 30, 60, 90 triangle. Now 30, 60, 90 triangle we know a little bit about. Because if I go back to, hold on, I'll show you. Go back to here. If I use this information here, I've got 2x, x squared to 3, right? So you can get the height of this triangle by using this little, or you can use trigonometry. Once you get the height of this triangle, you know how to find the area of a triangle. It's 1/2 its base, right? Times its height. It's equilateral, so its base has got to be 10, right? But you got to find the height, and that'll give you the area of one triangle. And then in the end of that, we're going to multiply all that by 6 because there's 6 triangles. Okay? So there it is. Okay, I set you up on all of these. Good luck. This is it. Have a great summer. I will maybe do a little lesson on Monday just to wish you all a happy day. Okay. So if you don't have everything in, get it in by Wednesday noon, and then grades will be done. Okay.